we derive that equation or that equation for the maximum addendum radius for the pinion and for the gear. Maximum addendum radius for the pinion and the gear. Now in this video we find out the minimum number of teeth on gear. Minimum number of teeth on the gear to avoid interference. Minimum number of teeth on gear to avoid interference. So how many number of the teeth should be on that gear to avoid interference? That derivations we derive here. So in this derivation we consider that notations like this. In that notation like this, capital T is the number of teeth on that gear wheel. Capital T number of teeth on the gear wheel. Small t is number of teeth on the pinion. Gear ratio again it is the angular velocity ratio. Gear ratio again it is angular velocity ratio of that gear wheel to the pinion, to the gear wheel to the pinion. Again this angular velocity ratio again we can correlate to the tooth of that particular gear and pinion. Tooths of that particular gear and pinion. So gear ratio is equal to capital T by T. Capital T by T. Gear ratio again it is a ratio of the number of teeth on that gear wheel divided by number of teeth on the pinion. Phi is the pressure angle or angle of obliquity. Phi is the pressure angle and angle of obliquity. M is the model pitch. D by T. M is the model pitch is nothing but the pitch circle diameter per number of the tooth. D by T. So now this AWM represent addendum of wheel, represent that addendum of wheel to avoid interference. AWM represent the addendum of the wheel to avoid interference, and this AW is the fraction by which that standard addendum of one module for the gear is to be multiplied. So it is a multiplication factor. It is a multiplication factor to the standard addendum, multiplication factor to the standard addendum of one model of the gear, one model for that gear, and so that we can avoid interference. So it is a multiplication factor to the standard addendum, so that we can avoid interference, for the one model for that gear, for that gear. So this is the multiplication factor. To avoid interference to that standard addendum of that particular wheel. Similarly, APM is equal to addendum of that pinion to avoid interference. So AP is the factor. So AP is the factor or multiplication factor to the standard addendum of that pinion. So that interference should be avoided. So these are the multiplication factor AW and AP for the gear and for wheel and for the pinion. O1P. Now O1P is the pitch circle radius. Now here this is considered as O1P. O1P pitch circle radius, and O2P is pitch circle radius for the wheel. O2P pitch circle radius for the wheel. O1P pitch circle radius for the pinion. So this will be represented here. O1P is equal to pitch circle radius of that pinion is equal to MT by 2. Now this pitch circle is nothing but M. Model is nothing but the pitch circle diameter. D by T. Model is nothing but the D by T. D is represent pitch circle diameter and T represent tooths. So model is nothing but the pitch circle diameter per number of tooth. Pitch circle diameter per number of the tooth. So D by T. So M is now represent D by T. So T get cancelled, and here remaining term is a D by 2. Nothing but the radius. Pitch circle radius, nothing but the pitch circle radius for the pinion. Similarly, pitch circle radius of that gear, m is now d by t, that t and this t get cancelled, and d by 2 nothing but the pitch circle radius of that gear. Pitch circle radius of that gear. So pitch circle radius here represented in terms of the model. Pitch circle radius is represented in terms of the model. Model is nothing but the pitch circle diameter per unit of the tooth. And this common tangent cut addendum circle at A and B. Common tangent cut addendum circle at A and B. Now this in this diagram, suppose for this gear or wheel, this is the base circle, this is the pitch circle wheel, and this is the maximum addendum circle for this wheel, Similarly for the pinion, with center O1, this is the base circle, this is the pitch circle diameter, and this is the maximum addendum circle for the pinion, So this maximum addendum circle, now we draw tangent to the base circles, draw tangent to the base circle of this pinion, draw tangent to the base circle of this wheel, a common tangent we draw here, Now this tangent cut this maximum addendum of that pinion and the maximum addendum of that gear or wheel, cut at this point A and B, So these are the maximum points. Common tangent cut that addendum circle at A and B. So these are the maximum points. Above this point interference will occur. So this is the pressure angle. This is the pressure angle. The pressure angle phi is the pressure angle, which is same for the gear and pinion. So phi is the pressure angle. So this diagram explained like this. So this diagram represent this base circle, pitch circle, and the maximum addendum circle. Now this pitch circle and this pitch circle come in contact at a common point P. This pitch circle of that gear and pitch circle for that pinion come in contact with common point P. Here, shown here, this is the phi, the pressure angle. Now we have to find out minimum number of teeth. Now consider this triangle BO2P. This triangle BO2P. For this triangle, now this is not a right angle triangle. For this triangle, we write O2B square is equal to. In this case, we write O2B square. O2B square is equal to summation of square of remaining side. Summation of square of that remaining side. O2P and PB. These are the two sides. O2P one side and PB is another side of this triangle. Now summation of square of this side and this side, summation of square of this O2P square and PB square minus 2 times O2P PB minus 2 times O2P PB and cos angle in between these two sides. Cos angle between these two sides is now O2PB. Angle between these two sides is a O2PB. So cos angle in between these two sides are the cos of O2PB. Now put the value of this length. O2P, now here we represented this O2P as empty by 2. So O2P is empty by 2. Put here. PB now represented as a O1P sin phi. PB represented as a O1P. Now for this right angle triangle, O1P sin phi. For this right angle triangle, this PB we can calculate as a O1P sin phi. So PB represents O1P sin phi minus 2 O2P again empty by 2. This PB again O1P sin phi cos of O2PB now, O2PB, O2PB, this triangle, this is a 90 degree up to here, 90 degree up to here plus phi, 90 plus phi. So cos 90 plus phi. Now simplify this, Now again O1P, is nothing but a mt by 2. O1P is nothing but mt by 2. So put in O1P is mt by 2, O1P is mt by 2, and we will get this expression. Now simplify this expression. We will get like this. Simplify this expression, we will get like this. Now take this t square common. Take this t square common. So inside this bracket 1 plus t square by t square sin square phi plus 2 t by t divided by t square. So 1t and 1t in this t square get cancelled and only t1 is remaining in the denominator. So 2t by t sin square phi. So O2b, take a square root of both sides. O2b now becomes as a mt by 2 and square root of this term. So this is the radius of maximum addendum circle of the gear wheel. This is the radius of that maximum addendum circle of the gear wheel. Now this O2b, again we can write down like this. O2b again we can write like this. O2p plus AWM. O2p, maximum O2b is O2b value. O2b value we can write as a O2p plus AWM. O2p plus AWM. So this will be written here. O2p plus AWM. Now O2p value is mt by 2. O2p value is mt by 2. That we put here mt by 2 plus AWM. Now this value again put here. Now O2b, again we have this O2b in terms of this AWM like this. So put this value into this equation. So we already get O2b like this. So equate the both terms. O2b we can obtain in terms of t and O2b in terms of AWM. So equate these two terms. Mt by 2 plus AWM is equal to this term. Mt by 2 and the square root of this term. So this term represented here. Now simplification of this. We will get AWM is equal to like this. Mt by 2 into bracket 1 plus t by t into bracket t by t plus 2 sin square phi square root of this whole term minus 1. So this AWM get cancelled. AW becomes now t by 2 into bracket like this. So we will get this value of AW. Now simplify this. Now t, we are interested in to find out number of teeth. On that gear to our interference. So this t now becomes this t. We are interested in find out t. T is equal to 2 into AW and remaining term we shift here. 2 into AW, remaining term we shift here. And now this is the desired equation. That we are interested to find out. So this t is nothing but a minimum number of teeth. On the gear to avoid interference. So this t is equal to 2AW divided by this term 1 plus t by t into t plus 2 sin square phi whole term square root of this whole term minus 1. So if number of teeth on that pinion is same, if this t and this t is same, in that case this becomes as a 1, and this equation now modified like this 1 plus 3 sin square phi square root of this term minus 1. And this term we can also write in terms of the g. This equation also we can write in terms of the g. T by t is nothing but a 1 by g. T by t is nothing but 1 by g. And we can write in terms of the g also. in terms of G also. This equation we can write in terms of the G also. So this is the minimum number of teeth on that gear to avoid interference. Similarly, we can derive minimum number of teeth on the pinion. Minimum number of teeth on that pinion to avoid interference. So this equation is useful when that model pitch is not given. When that model pitch is not given, then addendum is given in terms of module. Model pitch is not given, and that addendum is given in terms of the model. We use this equation to find out the minimum number of teeth. Minimum number of teeth to find out the to avoid interference. Minimum number of teeth to avoid interference.